that means the first unit on functions and transformations in Pre-Calc Excel has come to an end, and that means there must be some sort of test coming up pretty soon. So if you're listening to this, that means you have some questions maybe about some problems on that review and you want to listen in for an explanation, okay? Just so you know, this video isn't going to go over every single problem. It's going to go over some of them, and then depending on if any other questions come up from students, there may be a follow-up video that goes over sort of the other half or whatever I don't cover in this video. Other things to remind you of: as you are practicing, you can practice using any problem from your notes packets, any problem from the problem sets. Redoing problems is a fantastic way to review. All right, and while you're doing all of these, remember, no calculator, all right? Do them with your noggin and a piece of paper and pencil. Okay, so without further ado, question number 4. This question relates to function vocabulary and features. Okay, so if you need a deeper dive, watch the video on function vocabulary, and it will help you identify all of those things. So a couple of reminders: these things, x-intercepts, y-intercepts, these are points, so they are an x comma a y value. All right, domain and range, these are an interval. Okay, an interval of x values. And then increasing, decreasing, constant, also an interval, but they are called an open interval. So it's parentheses only for these guys. All right, here, in fact, I'm going to move that little note over here, parentheses only, okay, because they are an open interval. All right, so our x-intercept, remember, we're just going to look on the x-axis, identify the point where the graph crosses the x-axis. Looks like that point is 0, 0. And then I'm going to do the same thing for the y-intercept, which it turns out, even though it may not look like it by the way I just did that, is the same point. All right, 0, 0. Okay, the domain. We're going to look left to right. Okay, so what does that mean? That means start on the left side and ask yourself, what's the first thing you see as maybe your visual kind of looks to the left? Oh, the first thing that I hit as I'm looking is an arrow, okay? An arrow means we're thinking about infinity. So in this case, since that's on the left side, that's negative infinity. Okay, and then if I keep going, my graph jumps from here to here but doesn't break, and then it jumps again but doesn't break, and then it ends with another arrow. So this graph goes from negative infinity to infinity. Or if you don't want to use all real, like interval notation, you could use the all real number r. Okay, so what about the range? The range, you want to look from the bottom to the top of your graph, okay? So that means you want to start down here. And you want to visually think, what's the first thing I hit? Well, the first thing I hit is 0, and then I keep going. My graph looks like it breaks because if I'm looking over here on the right, but on the left, it doesn't break. It keeps going forever. So it goes up and up and up and up, and then again I hit some more arrows. So that guy goes up and up forever and ever. So it goes from 0 to infinity. Now, in this particular situation, I'm going to use a square bracket because this is a point. It is a specific identifiable location. It is not an idea of infinity, right? Positive infinity. Those things, infinities, they get parentheses because they are ideas, not actual numbers we are equal to. So that's why it's a bracket and then a parenthesis. All right, and then remember I said these guys are open intervals. So parentheses only, no matter what. Okay, so where are we increasing? Well, we're increasing here from 0 to 1. And remember, this is x values only because increasing is what the y's are doing. So I just want to know where, and where is x values. All right, we are also increasing, so union from here, so 2, for forever to the right, so towards infinity. So 2 to infinity. All right, and then I am decreasing over here on the left. So there's that arrow again. That arrow means I'm coming from negative infinity, and that's ending at 0. All right, and then I've got this little tiny chunk that's flat. That's my constant from 1 to 2. All right, now I want to make an actual piecewise function related to this. So I need to write a couple of equations, okay? So that's part A down here because we've got that table over there. So I'm going to use my highlighter for this. So this first shape right here that I'm highlighting, I'm going to write here. And then this constant bit, I'm going to write second. And then this linear bit, I'm going to write third. Okay, so you want to look for, when you're writing the piecewise equation, you want to look at those pieces and then ask yourself, what shape is that? And then if you know the shape, you know what that equation for that shape should look like. So like I know that this should be x squared because it's a parabola, a quadratic. And then I just need to ask myself, does it look like it shifted up or down? If I plug in, let's say 1, do I get out 1 when I square it? Yes, I do. Okay, and if you're all good with your equation, which it looks like we are, then you just need to say where x is greater or less. I don't know what it looks like. It stops at 1. So that means where it's x is less than or equal to 1. And remember, the less than or equal to is because I see a closed dot, right? Closed dot means you're equal to. Okay, next, that little constant bit. It has a height of 3. And it does that from 1 to 2 on the x-axis. Like if I look at the x-axis, that happens from 1 to 2 on the x-axis. Now, I'm going to put an equal to under the 2 because here we're closed versus open. All right? And then last but not least, I've got a linear piece in this yellow highlighted part. And so that's going to be some kind of mx plus b. So it looks like up 1 over 1, so x. And then if I imagine it going back, it doesn't go through the, it goes to the origin at 0. So that is it. It's just y equals x. And that starts at 2, so it's when x is greater than 2. No, equal to, because we have, again, open dot right there. Okay, and then anytime you're asked to evaluate, that means you're looking for one value. I want a value. And you can use the graph, or you could use your equation, your call. So these are all x. Like when x equals -2, what's the answer? So x equals -2, it looks like that answer is 4. If we're looking at f of 1, that's still on that same piece. It's 1, because that's where that closed dot is. And then f of 3 is going to be right here at 3. It's going to be right here. All right? So lots of ways to do that. You could use the graph or the equations, your call. All right, moving on to the next page. Again, if I have time, I'll maybe do this one later in a different video, but I'm going to skip that for now. And I'm going to move on to number 7, which if you need any help with this kind of problem, this is the transformations section. You might want to watch that video, or there's a couple of videos actually about it if you are struggling with transformations. Okay, so as a reminder, a times f of bx minus h plus k. Remember that a, that thing in front of f, and k, thing at the end of the parentheses, those are vertical, okay? And then everything inside is horizontal. And remember, vertical, I'm just going to use the letter V. The order is left to right. That's your order of operations. And then your horizontal transformations, remember, you want to go from the right side backwards to the left. You want to go this way. All right. So, and it looks like the only one, as I'm looking at these, the only one that's really going to have that trouble is D. Okay? So, like, for example, you'd want to make sure you talk about the fact that you are reflecting over the x-axis, dilating y by a factor of 4, and then you want to talk about shifting up 3. And reflect over the y-axis. Now, I could have said what I just wrote last. I could have said that first, and that would have been all right, because the reflecting over the y-axis is this negative in here. That's a horizontal transformation. You just have to talk about everything horizontal and then everything vertical, or vice versa. Okay, so like for example, I could do letter B by saying I'm going to dilate x by 2, because remember you have to take the reciprocal of that because it's the inverse of whatever's happening. Dilate x by, sorry, I should say factor of 2, and then shift up 2. I could flip those two things. I could flip the order of them, but I have to say both of them because there's just one thing happening to each variable. All right, so there's a couple of transformations practice problems. Okay, next we're moving on to using functions with all kinds of notation. There's a whole variety of things on using functions. So depending on what you need, maybe composition, which is different from combinations, which is different from notation. So if you need a little bit more help on the stuff on this page, you might need to watch one of those videos. Okay, so P of 23. I think pretty much everybody has a pretty good handle that if there's a number in the parentheses, you put it into whatever equation it's talking about. Okay, so that means I'm going to take the square root of 4 times 23 plus 3, which is going to get me 80s, 4 times 20, plus 12. So that's going to get me 92 plus 3, which is the square root of 95. Now, I just want to remind you that because we're looking for an output, means there's only one, right, output. There's only one per input. Okay, this is not a plus minus situation. The answer is just the square root of 95. Boom. End of story. Done. Okay? Nothing fancier to it. Just want to make sure we understand that. All right. So moving on. Things tend to get a little dicier for some reason when we say, hey, I'm going to put an expression in the parentheses. All this is saying is to take x, because x is a placeholder for whatever you want, and turn it into 2x plus 6. I get that there's an x on the left and the right side. All I'm saying is I'm going to take out x in the g function. So the g function is 2 times something squared, right? See it? Times something squared. Plus that something, right? Minus that something. Plus 7. Plus 7. Okay, so what's happening is we are dropping this expression into those parentheses, okay? So 2x plus 6, 2x plus 6, okay? And then just a whole bunch of algebra. We do 2, and then 2x plus 6 times 2x plus 6. There are two of those quantities. We distribute the negative. We carry down the 7, right? We don't lose that. So we've got 2, and then we've got 4x squared plus 12x and 12x, so 24x plus 36 minus 2x plus 1, because I combine some like terms. And then I distribute my 2, 1, 2, 3 times. So I get, and I'm just kind of talking you through here, but really this is just, you know, some review of like using all our different algebra skills. Order of operations, do what's in the parentheses first, you know, multiply the larger binomials together, etc. Combine like terms, all that stuff. And so then we should get 8x squared plus 46x plus 73 as our final answer. Okay, so that expression is g of 2x plus 6. Okay, so then as a reminder, this notation right here means find the inverse, okay, and of whatever function we're talking about. And in this case, we're talking about p, and p is this guy over here, so that's our square root of 4x plus 3. Sorry, find that of that function. So the first thing you do is you're going to say, oh, I'm going to set it to equal to x and make it 4y plus 3. I'm going to switch the letter x to the letter y, and then I'm going to solve for y. So I'm going to square both sides. So I'm going to get x squared equals 4y plus 3. I'm going to subtract 3. And I'm going to divide by 4. And there's a couple different ways you could write the answer, but no matter what, you have to write p inverse, because that's what we were trying to find, is. And I'm just going to go with like a big fraction, x squared minus 3 over 4. There's a few ways you could kind of break that apart into two fractions, but either way, that's your answer. All right, and then let's do one more problem that I get a lot of questions about. So this one right here, h. So the x plus k, I get that it's two letters, but it is the same problem as this guy over here, letter E. And then there's just some other stuff happening in addition. So h is this function right here, x squared plus 22. So h of x is x squared plus 22. So that means h of x plus k would be x plus k squared plus 22. Because notice, I took the x and replaced it with whatever was in the parentheses. All right, and then that means that the actual notation I'm dealing with, like this fraction, here I'm going to write it in orange, would be x plus h squared plus 22, that thing, minus x squared plus 22. And you can use square brackets or regular parentheses. When you're just doing algebra, square brackets are just another type of parenthesis. All right, and then I just, again, have to do a whole bunch of algebra. So x squared plus 2xh plus h squared plus 22 minus x squared minus 22. All that nonsense divided by k. Okay, so the 22s are gone because they add up to 0. The x squareds are gone. So I'm left with 2xh plus h squared. Oh my gosh, guys, so sorry. We've been doing all these problems with the h's, so I accidentally wrote the letter h instead of the letter k. My bad. So sorry. Those h's should be k's. Okay, which actually that kind of worked out because now hopefully you can see that they're in both terms, and that's why we end up with 2x because the k divides out plus k. All right, and that is our final answer for that problem. All right, thanks for listening. There will very likely be one more video, so hopefully if there's still some problems you have questions on, you will be able to find your answers there. Thanks so much and have a good day.